Question 11. There's a few ways of doing this, but I think I'll show you what most students were doing. So they were putting a theta in here and using a cosine rule. And the cosine rule was that a squared equals b squared plus c squared minus 2bc cos a. Rearranging that to give, what's this? This is 2 times 13 squared times cos theta equals 13 squared, 169, take away 10. And so cos theta equals 169, take away 100, sorry, I put the square there, all divided by 2 times 169 on the bottom. And working that through gives you that makes theta to be, and we need 4 significant figures after this. So for 4 significant figures, I'm getting 0.7896. And now I'll go back to part A. And part A, the area of a triangle is a half times one side times the other times the sine of the angle between them. And this should give us 60. Shall we check it? Let's put it in here. So we've got a half times by 30 squared times by the sine of the angle between them gives us 60.00. So, okay, I'm going to put 001056, which equals 60 centimeters squared. Finally, you're asked to part C to find the shaded region, and so the shaded region is the sector take away the triangle, and the sector area is a half times the new radius. Is not 13 now, is it? It's 17, so it's a half r squared times by theta, and that works out to be 114.1. So now take away the 60, and it gives us 54.1 centimeters squared. And that's what most people did. Just to alert you to the slightly easier way, the slightly easier way was to actually divide this into 2 right-angled triangles. And if you divided that into 2 right-angled triangles, this is 13, this bit here is going to be 5 because it's half of 10, and actually you've got a nice Pythagorean triangle there, Pythagorean triple, that bit there is 12. And so that made the area here just a half times 10 times 12, there's the 60. For this bit here, you just needed to do a standard right-angled triangle with a 5 and a 13 and an inverse sine. But look, both ways are perfectly fine.